So hi everyone, thanks for having me and thanks for letting me present remotely. I can't make it out to Denver until Friday, but I'm really looking forward to hopefully meeting a lot of you all in person. So yeah, the work I'm going to talk about is work that I've been doing with the Move core and Move innovation teams at Mysten, as well as with the Sweet developer community. And of course, what I really want to talk about is how we go from having a safe smart contracts and a great smart contract language to a really great language for developing powerful apps. So this is a friendly audience, so I think I can say, I think Move is the best smart contract language, and I think it has been for some time now. But when you zoom out and you really think about it, and look at the big picture, smart contracts are really only just one small part of a Web3 app. If you look at a typical app, it's going to be reading state managed by Move, and that's going to be doing that a lot more often than it's sending transactions that touch Move. You're going to be sending new kinds of transactions a lot more often than you're going to be writing new smart contracts. And then if you look at all the code in an app, the amount of front end and back end code, glue code, everything that's not Move is going to dwarf the amount of smart contract code that you have. And so as language designers, I think it's really important that, of course, we're looking at smart contracts, understanding what they want and evolving the language in accordance with that. But we also need to spend a lot of time writing apps, working with app developers, looking at app code, figuring out what the needs of app developers are. And so the challenge that we've been taking on for the last couple of years is really getting deeper into that side and figuring out how can we evolve Move with these win-win abstractions that serve both the smart contract developer and the app developer. So here's the agenda for the talk today. I'm going to start off by talking about 3 foundational Move improvements that we think give devs special superpowers that aren't available elsewhere. And I'll talk both about sort of the theory and design of these features. And then I'm also going to make it more concrete by giving you examples of Sweet apps that leverage these features. And then I'm going to end with a much shorter preview of 2 new superpowers that we're bringing to devs in early 2024. So let me start off. I think there's basically 3 foundational improvements that we've made in Move since the DM days. And so I'm going to go deep on each of these. The first one is the object data model, which we think is the core abstraction for building smart contracts. The second is programmable transaction blocks, which give you the ability to dynamically and atomically compose code from the client side. And then there's dynamic fields, which allow you to glue together objects to add or remove data on the fly. It's a powerful primitive for object composability. So in the object data model, let's start off by looking at the code on the right and see what I mean by a core smart contract building block. So if you're declaring an object, you just do it like this. You have a struct, you give it the key ability. When you give it the key ability, its first field has to be of type UID. This UID is a globally unique identifier that you can use to distinguish the object from other objects inside Move code, as well as in RPC and in clients and anywhere else up the stack. Transferability is also built in. If you want the object to be freely transferable, you just give it the store ability. And then there's a native function for transfer that lets you transfer the object to an address, to another object, or whatever else you would like to do with it. And then if you want the object to have fields, you just add them like a normal struct. You'll be able to see those from the client side as well. And so with this, you get native implementation of a lot of the key things that you need for pretty much any smart contract use case. You have unique identifiers, you have transfers if you have the store ability, and then of course also object ownership, which lives in the object metadata outside of Move. So if you look up an object via an RPC call, you'll see a field called owner, and that field can mean a couple of different things. It can say, I'm owned by an address, I'm owned by another object, I'm shared, which means anyone can access me, or I'm immutable, which means anyone can access me, but they can't do any writes. And the other thing you get with objects is there's client-side visualization. There's a display standard, which you can implement inside of Move. And then instead of just seeing the JSON representation of the object, it'll render the object in a way that's nice for explorers or clients or wallets to look at, fetching images when you see an image URL and these sorts of things. So what do Sweet objects do for app developers? So I think maybe the first and most important one is that owned object access control checks are performed by the Sweet runtime. So if ownership is instead an application concept where you have to, as a dev, over and over again, set up this policy of, hey, like this is the object owner, so only they can touch it, check and add an assertion for that in every function, it's really, really easy to miss a check. And if you do that, you have an access control vulnerability. And then also, like, even if you never forget, you have these manual checks everywhere that add a lot of boilerplate, and I think really end up constituting a lot of the code in total. The other thing I've sort of been alluding to this is that objects give you this consistent vocabulary throughout the stack. So Mood developers create objects and identify them by ID. APIs read objects, also use this ID as a handle. If you have apps or wallets or explorers, you display objects. It's this very direct representation of what's going on, instead of having these layers of translation or indirection in between what's going on at the move level and what's going on higher up the stack. The other thing objects lets you do is you can have these advanced standards like kiosk or closed loop tokens that program against the ability to do polymorphic transfers and to have native ownership. And if these are application level concepts, this is more difficult because they have to program against a specific implementation of ownership and transferability instead of the native one that everyone gets. And then finally, with native object ownership, this talk is mostly about what we can do for programmers, but you can get really low latency transactions, like half-a-second settlement finality, if your transaction is only touching owned objects. And the reason you can do that is because you have this native ownership information you can trust rather than ownership as an application feature. So let me give you an example of an app that's using objects in I think an interesting way. So something that Sui developers are starting to do is using these, creating these apps that use the ability to send objects to basically a stranger to a friend for onboarding and allow them to claim them via a link. So there's one prototype of this called zk-send that you can check out, where in zk-send you have a Sui address and it just looks sort of like a normal wallet. You can see what coins you have, you can see what NFTs or objects you have, and then you can select any of them or select a combination of them and you can create a claim link. So here, like I'm creating a claim link that has 0.1 Sui inside. And then once I click create link, I get what you see on the right-hand side here. There's a QR code or a link text that I can copy. And then I can send that to a friend via email, via text message, on Slack, whatever. And then what they see when they open the link is they say, hey, here's what's inside. In this case, the 0.1 Sui, your asset is waiting. They can connect a conventional browser plugin wallet to grab that. They can sign in they can use ZK Login and sign in with Google or Twitch, as you see on the screen here, to just grab that object that's been sent. And then what they get is basically going back to the other screen. Now they've got their own Sui address that has this object inside. And then this thing is all encapsulated in the zk-send SDK, which supports the Connect wallet standard. So they can take that object, connect to an app that uses it, and then just be off and running and using the app right away. So this is a really powerful thing because, before you had to have this wallet install barrier, grabbing Sui barrier, all this stuff, but you can go straight from clicking on a link to using an app on Sui pretty much immediately. And let me explain how objects are being used under the hood to allow you to do this. So, okay, how does the create link page work? It has a Sui address. There's an RPC method that says, hey, give me all of the objects that are owned by this address. And it just basically shows you all the objects that have store, which means that they're freely transferable and then can be used to create a link. And then it's using this display standard that I mentioned to render the object in this nice human readable way. And so what this means is that for any object type T, the zk-send app, it doesn't need to explicitly support T or add a new integration for this new object type, nor does the creator of the object type T have to say, hey, I would like I give permission for this to be used in zk-send or enable the app or anything like that. They both just use objects and don't have to know about the other one. So the way the create link functionality works is that you transfer objects to a temporary account A, and then when you claim them, you're scraping the objects from this temporary account A to a wallet or ZK login address, and that's using sponsor transactions or a gas coin that's included in the object bundle. So you can have links that anyone can claim. You can also say, hey, this link can only be claimed by a particular email. I want the sender to be able to take it back after some delay, whatever constraint you can express in a Move smart contract. So there's a real superpower for app devs in terms of onboarding and growth. You can send assets to anyone with an email without any wallet install, and then they can use it right away in any app that supports a zk-send Connect wallet. So the other thing I want to mention with objects is how they can make RPC better. So we've recently rolled out this RPC 2.0 that has this really nice GraphQL powered API, and this is really leveraging this principle of objects being the common vocabulary throughout the stack. So with GraphQL, one of the big problems I think with conventional RPC is that everything is done in terms of view functions, or if you're doing sort of a map and filter over a large set, you'll end up doing a lot of pagination, which requires repeated API calls and a lot of latency between the client and the full node or the indexer. And with GraphQL, you can instead put that all into one compositional query. The map filter happens on the GraphQL side where things are very efficient, and you just get back the final result without any pagination unless the final result itself is large. And so here's some examples of things that you can do with this new RPC. You can say, please get me all of the transactions that touch an object. This is what the query example in the top right is doing. And you can see that it's pretty concise. And also, like, it's looking both at move stuff, like object IDs, and transaction stuff, because it's in GraphQL. You can do things that you couldn't do in a view function, because a view function, say, can't look at the transaction history or things like this. You can say, get me all objects of a specific type. You can say, get me an object and give me all of its dynamic fields, both directly and transitively. You can say, give me all the objects whose owner matches some filter. Maybe the owner is this SWNS name. You could say something like, get me all the addresses that own both NFT A and NFT B. These sorts of things are really useful for promotions or analytics. So I think we have a whole talk just on what this new RPC 2.0 is letting you do. But the thing I want to highlight here is just that because everything is an object, you can really build RPC layers around being able to leverage that structure and expose it to developers in a way that lets you have these very nice queries. Okay, let me talk about the second fundamental change, which is programmable transaction blocks, or PTBs. So what these let you do is they let you have dynamic and atomic code composability and do it from the client side. So in SWE, everything you send to the network to do a write is a PTB. A PTB can contain up to 1,024 move calls. And so obviously you can use this for things like batching. Instead of having to have a smart contract explicitly support batch APIs, like for batch payments in SWE, you just expose a single call, and then the PTB can do the batching. So this is good for batch payments, batch NFT minting. But I think where PTBs get really interesting is when you do heterogeneous composition. So you call a function, it takes some input objects, some output objects come out of it, and then you thread those input objects into subsequent calls as inputs, and then maybe you do this repeatedly. And then of course there's this aspect of you can construct PTBs dynamically on the client without publishing any new smart contract code or without writing any move at all. So let's take a look at the code at the bottom here. This is this is some code from Scalable, which is exposing an SDK that's built on top of PTBs. So they create a PTB here, and then they expose a TypeScript function for each move function that they want in a PTB. And you can see basically like we're kind of writing move inside of JavaScript, or at least composing move inside of JavaScript. Like we call txblock.openObligation. That's calling a move function, and then we get back the objects that move function will return directly here in TypeScript. So here there's an obligation key, and a hot potato. We're going to call some additional functions, and then we're just taking things like the hot potato and passing them back into another move function. And then at the very end, we say, okay, back this all up, sign it, and send it off. And then each of those function calls will execute. If one of them fails, the whole thing aborts. So you get the same atomicity that you would get if you were publishing a new smart contract, but with the convenience of being able to do this on the client side. So let me zoom out and explain more generally what I think PTBs let you do. So I think they give you a solution to this thing that I'll call the Expedia problem, where I want dynamic and permissionless atomic composition. So maybe I want to buy a train ticket from Chicago to New York, and then I want to buy a hotel in New York, and then a tour of the Met. But ideally, I only want the hotel and the tour if the ticket purchase succeeds. There's no use, of course, in having a train ticket if I don't have some place to stay on the other end. And in this setup, there's going to be a lot of different vendors for each of the tickets, the hotels, and the tour. And these vendors, they shouldn't need to integrate with each other or even be aware that the other vendor exists. They shouldn't need to implement any common standards, and they shouldn't need to give the aggregator any permission to use their data to smash things together. And on the aggregator side, you want to be able to bundle any combination or number of vendors. Like if someone wants to add some additional tours on top of this, maybe buy a return ticket, whatever they want to do, they should be able to do that. they should be able to make these choices on the fly and do it per customer, per query. They don't want to publish a smart contract for every possible combination that we can have for each of these vendors. And so if you think of, in this setup, the vendor is really just a move package that's offering a particular asset, listing something for sale, and then the aggregator is really just a PTB app that doesn't even need to publish any new smart contract code itself. It's just composing stuff that's already there on chain and getting atomicity, the atomicity that you want via PTBs. So, you might be saying, like, Sam, this seems a little bit abstract. There's nobody selling train tickets or hotels on Sui, at least not yet. But there's actually a lot of things on chain that look like this, and I just chose this example because it's a little easier to understand. So the thing that looks like this the most on chain today is where vendors are DeFi protocols, and they're offering interfaces for swapping tokens, and you have something like a smart router that wants to be able to compose many different protocols for swapping tokens in order to take advantage of an arbitrage opportunity, or maybe get the best price for moving from one token to another, these sorts of things. So here's one example of an interesting kind of PTB. Someone borrows some funds from a scalable flash loan. They do some swaps on the Aftermath, which is one DeFi protocol. They then do a swap on CreateX, which is another DeFi protocol. Then they do another swap through Cetus, which is yet another, and then they finally repay the flash loan. So I got this example by just asking a Sui developer group, like, can you send me some interesting PTBs, especially ones where they do things that you can't do elsewhere? And what the developer said is that this one is interesting because it integrated with 3 different DEXs, and then it used this flash loan. If I were going to do this in the EVM, it just wouldn't be possible to do unless I wrote this very complicated proxy contract. So with the PTB, this code ends up touching 4 different protocols. None of these protocols have explicit on-chain implement common interfaces or do any sort of explicit integration with each other. The APIs, in fact, for swapping are all quite different. The PTB is able to just glue them together by passing objects from one to the next. There's no new code that was published, and the gas fee is very low, a lot lower than it would be if you were sending separate transactions to do each swap, and then also you wouldn't get the atomicity. So these are a real superpower for DeFi builders. There are these smart routers like the Scalable smart router. There's one from Aftermath, and I think there are many, many more things that are going to look like this as there are different kinds of vendors that come on. The final point I want to make here is that PTBs are very commonly used in the top packages. Like, I'm not just sort of cherry picking examples here. If we look at the top 15 packages on Sui by DAU over the last 75 days, we see that the most PTBs are calling 5 or more move functions. It's not the case if they're just calling 1 or 2, and sometimes they're calling a lot more. Very, very consistently, they're using fairly complex PTBs to get their job done. So developers really like this feature, and in top apps, they use it a lot. Okay, finally, let me talk about dynamic fields. So this is a data composability feature. It lets you add or remove objects, fields to an object on the fly. So here we've got an object declaration. It's got its unique ID. It's got a normal field F that's of type U64. And what dynamic fields let you do is you can also attach fields that weren't declared as one of the static fields. So here I've declared a function called add coin. It takes the object as input. And what I'm going to do is, this object, I now want it to have a balance in whatever coin type I want. And so the way I do that is I say, okay, get me the type name of this coin, a little bit of reflection. And then I say, o.id of t, give me a 0 balance in that coin. And I can call this with as many different t's as I want, and then the object will have a balance in each of those kinds of coins. So you can do this directly in the declaring package, as I've done here. If you start off with a static object structure and decide later you want to add some fields without asking folks to do a data migration, you can upgrade your package with a function that adds dynamic fields later. You can even expose the idea of your object to external packages if you want to allow other folks to add fields on top of your object. That one's a little bit crazier, but there are some use cases where you want to do that. And finally, objects have a size limit, but with dynamic fields under the hood, it's just creating a separate object and then attaching it to your object via ownership, so you can add as many as you want, and they don't count toward the object size. So, okay, what do these dynamic fields do for app developers? So for one thing, this is how large collections work under the hood. If you're using a table or a link table, it's just dynamic fields that are stitching objects together and allowing you to look up an object by a convenient key instead of by an ID, like a string key, an integer key, whatever you want. You can also have heterogeneous collections like bag that doesn't have to, where the elements in the collection don't all need to be the same type. You know, you could have a bag of coins where each coin is a different coin type. You could have the zkSend the zkSend app actually uses, you could have a bag that has an NFT and then it has a coin and has some different NFT, and then you transfer them all as one unit. We expose dynamic fields directly so programmers can use them to implement custom collections. Like if you're implementing an order book, it's probably going to have a crypt bit tray under the hood. Folks use dynamic fields to implement this. As I mentioned before, this allows you to have extensible and upgradable objects. And then I think the really sort of more producty or app developer thing is that you can have these composable object hierarchies. If you have an NFT that has accessories, if you want to have a game character with an inventory, if you have a DOM element that has some children underneath it, if you're doing a lending protocol and you want to represent a multi-asset deposit, dynamic fields are the right way to represent all of these different things. Let me give one example of an interesting use of dynamic fields. So this is talking about Sweet Friends and Pebble City. So Sweet Friends is an NFT collection on Sweet, and Sweet Friends are, like this little guy here. It's a character that's sort of blank, but then it can also have accessories. And so in this case, what happened was at first it only had native accessories like this. These ski goggles were a native accessory that any Sweet Friend could have. But then Pebble City, this game launch and Sweet came along and said, hey, we'd love to do a cross promotion with Sweet Friends where we have our own Pebble City accessories and we just want those to go on the Sweet Friend as well. And so this is kind of interesting because it's like the accessories are coming from different issuers, but because of dynamic fields, they can both be attached to the same underlying NFT object, even though the original code for the NFT object didn't anticipate that. And so the way this works is that there's the Sweet Friend object, there's a dynamic field with key eyes, and there's a dynamic field with keys torso, and that basically says like, here's the object that's going to be on your eyes or on your torso. And then there can be different accessory types on each. Like here, there's this goggles accessory, which is of one type, and then there's this jacket accessory, which is of another type. And the other cool thing about these accessories is that we use kiosks to attach royalty policies to them. So when you sell one of these Pebble City accessories, there's royalties that get paid to the Sweet Friends creators and to Pebble City, which is kind of nifty. So you can see that like these sort of first-party and third-party objects compose seamlessly, and this is really useful if you're building NFTs, if you're a game dev, if you're a social dev. These folks love this feature. Okay, so that concludes the first part of the talk, and which is the majority of what I wanted to talk about. I'm going to close with a preview of two new superpowers that we think are really useful for app devs that are coming in early 2024. And so these two features are safe and composable on-chain randomness. You get native randomness that you can access directly from a smart contract, and you pair this with the flexibility of PTBs to do all sorts of interesting things. And the second is what we call a move to app compiler, which lets you go from move code to an end-to-end working app much faster. So yeah, secure, flexible on-chain randomness. This is coming to mainnet in Q2 this year. It's been working on it for a while, but these features, one must be very careful to make sure you get it right and have it be secure. So the way this works is that there's a new random type. You can generate random integers, random bytes, random strings. You can shuffle collections randomly, all of this sort of stuff. And to make with randomness, like you must be very careful that someone can't write code where it peeks at the outcome of the randomness and then decides to do something different. It makes it really easy to say game a random NFT mint or game an on-chain casino or card game or these sorts of things. And so the way we deal with this is that if you're using this special random object, it has to be the last call in a PTB, and it has to be private entry, which means someone can't look at the return value and do something that they shouldn't do. So this combination of things gives you the full flexibility of PTBs. Before the usage randomness, you can do whatever you want, but it also prevents attacks that peek at the result. And this is pretty important as compared to just calling the randomness directly, because the folks who want to use this on Sweet, almost everything they want to do involves PTBs and doing things beforehand. So maybe you want to use an on-chain multi-sig wallet to mint a random NFT. That'll require some PTB calls to do the multi-sig wallet approval before you actually call the random function. One protocol building on the randomness has vouchers as an onboarding mechanism that allows the house to pay for the first game. So that works as a PTB that first redeems the voucher and sort of gets the token to allow you to play the game, and then it calls the actual random touching code. So this is just an illustration of, okay, we got this new feature of randomness, and then it fits well with this existing PTBs to give you lots of flexibility. And so the second thing is a slightly different kind of advance. This is what we call the move to app compiler. And so the context for this I alluded to briefly, but basically, if you look at a typical app on Sui, I think other platforms like this too, it's maybe 5% move code and 95% code front end and back end and sort of other stuff. But if you look at the move code and you've written a bunch of these, you can imagine a lot of what the app is going to look like. All of the intent, a lot of like interesting stuff that's going on is captured in the move code. So the idea that we have is, how can we leverage the really nice structure of the move code, and in particular the sort of objects it exposes, to automatically generate a lot of that 95% for you. So there's some very low-hanging fruit here: TypeScript type definitions, serializers and deserializers, function bindings, PTB construction, useful GraphQL queries. These are all things that today you'd write them manually, but they're fairly rote if you already know what the move code is going to look like. So the goal that we're working toward here is we want to be able to generate an app that works end-to-end from move source code. Now, this isn't the sort of app you would ship. This is something where it's useful as an interactive visual aid for testing or prototyping, and maybe it gives you some starter libraries that would be useful for building a real app. And once we do the code gen, maybe we plug an LLM into the picture and help it help you iterate even faster by building on top of these nice libraries. But that's a bit further afield. I think the thing we want to do first is do the deterministic generation that gives you something very reliable. And so we're working on taking the first big step toward this. There's a really cool community tool called Sui Client Gen, which generates type-safe and PTB-friendly TypeScript function object bindings. It can start from move source code or bytecode. So if you look below, here's an example of what you would get. This create pool with coins function is automatically generated from the move code. It gives you these nice parameter names that it pulls from the source. It uses the same function name. It ends up being a lot easier than having to write the stuff yourself. And also you change the move code, and of course this can be regenerated automatically. So this exists as a standalone tool today. We're working on upstreaming into the Sui CLI, so you can just run this as part of your build process and get started with a nice skeleton for an app. So I've talked that's all I wanted to go through today. Let me just conclude. Talked about how we can go from safe smart contracts to powerful apps. Started by talking about objects, which provide this consistent vocabulary throughout the development stack. I alluded briefly to this, but zk-login and zk-send SDKs are powerful because they can give app developers access to a much broader audience than just the installed wallet base. PTBs give you dynamic and atomic composability directly from the client. Dynamic fields do the same thing on sort of the data side. You can compose objects to enable rich assets. And then finally, we're working on Move to App Compiler, which helps you go directly from move code to a working prototype app, or at least well in time. Thanks so much, and happy to field any questions. Will zk-send be functional beyond the token standard? Yes, so the thing with zk-send is it doesn't actually rely on the token standard at all. It's just looking at objects. So there's an RPC call that's called get objects owned by address. zk-send is associated with a particular address, and so it'll show you all of those objects. It'll then filter by ones that are transferable because some objects are soul bound or have conditions on transferability. And then you can create a link for any of the objects that are transferable. So that includes coins, of course, but it also includes NFTs, permissions, anything that's transferable, and then it uses the display standard to display them. So the author of the object doesn't have to implement any special standards in order for zk-send to support it. Basically, as long as your object has the key and store abilities, it'll support it automatically.
Yeah, maybe follow-up question. Is it possible to trade accounts safely in Sui?
So I'm not sure if I understood what's meant by trade account, but let me say a couple of different things. You can tell me which one you mean. So I think one might be like, can you rotate the key that's used to spend from accounts? Like that you cannot do. The address is associated with a particular authentication method. Something you can do, though, is that because all objects are transferable and the PTB has this transfer objects command that lets you transfer multiple objects at once, is that it's very easy to migrate all of your objects from one account to another. And that's something we actually use all the time. Like object in idiomatic move code, you're not authenticating based on address anyway, you're authenticating based on capabilities. So if you have all your objects in one account and you're like, hey, I'd actually like these to be a multi-sig now, then it's easy to migrate all of that in a single PTB to a new address that has a different authentication scheme. But in terms of being able to rotate the authentication for an address, that you can't do. It's statically bound. What are the differences between a sweep PTB and a move script, if any? So the key difference is that a move script has to be written by a human, then compiled, and then published as part of a transaction, whereas a PTB can be constructed on the fly in the client. And so from an expressivity standpoint, these are basically the same, like they can express the same things. But in terms of how you actually use them as an application developer, it's extremely different. So for example, I talked about this ticket and hotel problem. Like there, imagine the case where it's like, oh, somebody wants to buy a hotel from this vendor and somebody wants to buy a ticket from this vendor. Then if you imagine doing this with a PTB, then it's easy, you know, call the function that's talking to the ticket vendor, call the function that's talking to the hotel vendor. You do that from the front end, you're off and running. Whereas if you're using a script, what you have to do is manually write the code that says, okay, buy from this hotel vendor, buy from this ticket vendor, and then you compile that and then you publish it. That requires a human in the loop, a PTB would not. That's basically the fundamental difference. All right, thanks a lot, everyone. Hope to catch you on Friday or Saturday.